Hello friends. Today we discuss the Python course. So today we discussing the designing with exceptions. In previous we discussed the exception basics and exception handlings. What is exceptions? When the interpreter enter an error, it stop running the program and show an error message detailing the exceptions. Why we use exceptions, and then we discuss the exception, the short story, and then the exception handler, and then we discuss the exception codings, then we discuss the exception objects, and today we discuss the designing with exceptions. So in that we have discussed the nesting exceptional handlers. In that we have we have discussing that for the matter what does it means if we try calls a function that runs another try. Typically, try statement can nested in terms of both syntax and runtime control flow through your node codes. I will mention this briefly. Let clarify the ideas here. The both of these cases, understand if you realize the Python struct try statements at the running time, the exception is raised. The Python return most of the recent entered try statement with a match expert clause. So that is a mean that each try statements leave and marker. Python can jump back to the earlier tries. In that, like a nesting, in try, there is another try and else an exception clause, and after that outer exception clause is there. In that, so both that is the case of that nesting. Oh, okay. And this nesting of active handler is what means when we talk about the propagation exceptions to up to the higher handler. Such handler are simply try statements enter earlier in the program execution flows. So like we have okay, so we have okay, for that designing that we have okay, for that designing we have okay, try statements. So we have okay, we have we have a try and then function one with like that. So okay, here it is. Yeah, here are the examples. Like we have okay, we have to draw it. Okay, so just to create new documents. Here it is. Yeah, for that we have okay, here it is. So we have to draw okay, here it is. So we have insert like this and draw something like this. Yeah. Okay, so here it is something like this, and we have also some insert also something like this, and okay, and then another insert we have, and third block like we have an insert like this. Yeah, so here it is. So and then we have okay, here it is. Okay, yeah, here it is. Okay, so we are just copy that code like we have okay, so we have like a try. So earlier we discussed like this, something like this. Yeah, just copy this, and just for that copy we have to something like we have, yeah, for that we have to be, yeah, to un like this, and we have okay, just this drop that, and we have funk1 this way, and then we were like x not here, simply e is there, and something like this. Okay, yeah, just copy this and okay, so we have like this okay, this way. This is a yeah, okay, that is. And then we have like a function, yeah, def. Then we have like sorry, small one, def, then func one, here it is. Then we have colon, then we have uh, same thing is there. Yeah, okay, this like this way. And okay, yeah, this way. And third block is for like we have function, and then we have in that function we have function 2, like function 2. So just increase the brightness like this. Okay, so we have a function 2, then like accept, and then okay, in that function we have like okay, let's copy this and just then we have like something like okay, mm, something like this. Okay, yeah, okay, and just copy this. Okay, just copy the same as this and just do the sorry, not this. Okay, okay, this way, and just do that. Okay, here it is. The all should be in the same format, I think so. We all click in the same shot of this. Okay, okay, it is. This is the okay, yeah, I get it. This is fine. Okay, here it is. Yeah, yeah, it is fine. Oh, it is. So like, so we have like okay, so we have like nested try except statement. When an exception is raised by you or by Python, the control jumps back to the most recently entered try statement with match except clause, and the program resume after the try statements. The except clause intercept and stop the exception. They are were process and recover from the exceptions. For that, like we have for that in that okay, we just copy this things. Okay, and just like this. Okay, let's go this way. Okay, okay, yeah, it's fine. Okay, another try statements. Okay, that's fine. Yeah, it will fine, I think so. Yeah, it's going inside. Okay, yeah, it'll fine. Yeah, okay, so we in this we like for that figure, like if we run the Python program, then try and function one. So function one is like we say like it's like it's a calling to that function 1 is called to the function func1 is function that call to the function 1 this way. It's called this. Yeah, so it's called for that. And then and then function 1 is run and try and function 2. So function 2 is called to the function func2 call to the function 2. Sorry, and this to be a true. This is to be a 2. Yeah. Okay. Yeah. So it's a function was called to this and then try and okay, something is to be. So it is function 2 and not try, something like printing the exceptions, printing the printing the hello, printing the h, sorry, small letter I printing the h high this way. Yeah, so it's fine. Okay, so this try and the function 1 is called to this function and try and function 2 is called to this. And this if we have an exception, then we have okay, it is. So we have we have the raised okay, then we have okay, so this to be removed and this try has some rise the e. Yeah, so we rise the e and that okay, and then function 1 that tries, then function 1's, then func1 calls to the function and then try and function 2 calls to the function and then try rise e. So rise e then accept and goes to back. Okay, here it is. So it goes to back. Okay, that is. Something is supposed to be okay this way. So function will rise is goes to an e in this e. Okay, yeah, here it is. So rise goes to e this way, goes to this e. Rise then rise except that create that e as an exception, then it goes to accept, go to that this block exception e, then print something like the then printing like this yeah, printing, yeah, you can say goes to something like we say e, we say also can we goes to printing x, yeah, printing e this way. And okay, that is okay for that okay, then the printing the e is there, and then this is also not x, this to be yeah, yeah, you can say printing the e and then it goes to the we say rise the e. For that e again e rise the e, you can say rise the f, rise the f is there, here it is. Yeah, this to be a pretty much good, I think so. Yeah, so like this. Okay, here it is. So if this rise e is goes to this except and then print e and then we say rise f. So rise f then is go to this and again does not, okay, yeah, okay, yeah. So this rise f will goes to this way, this f and then printf. So this way you're getting like printing exception e first and then printing f. And like, so in that we have see that illustrate what occurs when try statement with except clause nested at running time. The amount of code that give into a try block can be substantial. It may contain functional calls, invoke the other code, uh, watching for same exception. When an exception is actually raised, parties jump back to the most recently entered try statement that name with exceptions run the statement exception clause when the resume exception after try. So that this is a control like we have that control flow is there. Okay, in that in another case like we have okay, here it is. So we have like okay, here it is. Like we have try, then we have func one, then we have like finally. Yeah, there is a finally. Okay, finally something like pretty much exit, you can say. Yeah, you can say like let me say by. Yes, there. Yeah, okay, here it is. Yeah, you can say by. Here it is. Okay, yes. And then we have function 1, then we have try function 2, and then we have like a finally. Here it is. Finally, we say then in mid, like this way. Okay, here it is. So we have yeah, it's good. Yeah, it will work fine here this way. And this is a yeah, function 2, then we have try, then we say rather rise e only. You can say try, and then we say the rise the rise e, and then like rise e, and then is going to be rise e, and that we say finally, and then say the except clause, except e, and say like this way, and okay, and we say like this, and then we say, so we have like except e's, and then we print the like say enter. So this way like we have so in that case like okay, is function 2, then with this way, and we say like draw okay, yeah. So in that like function 1, and try is when the program is run. So first program is run by this block, then we try, then func1 calls to the function 1 this way, and then function 1 block is run, try is there, and func2 call to function 2 calling, and then we are try, then rise e. So rise e will like accept e, then is it printing the enter, and then we go to the finally. So finally is always run whenever the exception is there or not. So finally, and then printing the mid, and then it goes to the like okay, this way, and then is goes to, then after that is goes to this, and this after that it goes to the this. So this is a, like a cycle of that. In that try and final statement, when exception is raised here, the control return to the most recently entered try to the run it finally statement. But when the exceptions occur, propagates at all the exceptions, all the finally all active try statements, and eventually reach the default top level handler where the error message is printing. The finally clause intercept and okay, this way. So okay, here it is. So we have jumped to the like example control flow nesting. For that control flow we have okay, this is okay, here it is. For that we have like uh, we have like actions. So we have let def, then the actions is there first, and then we say like this, and say like printing the printing the okay, here it is. It is okay. So we have like a printing that at e. So in that action we have like so for that we have like printing the e. Here it is. So here it is. We have like okay. So we have like printing the like colons. Okay. For that we have like here it is. For that we have like printing the okay, this is not 1 plus 1, then empty list is generating the type error. Okay, like 1 we have integer plus list, so cannot be possible with the creating the generating the type error. And then we have like so we have like here it is. Okay, we have like okay, we have def, then action 1, action 1. This is action 2, sorry. Yeah, this is action 1 and a colon, and we say like try, and we say like action 2 call. After that we have accept clause, then we have try type error, then colon, and then we have like printing the inner try. So this is a printing, so this is the inner try. So we have like inner try is there, and then we select outer try is this, and then we like action 1 this way, and we say like this, and we like accepts, then we type error colon, then we say printing outer, the outer try. Here it is. we have like outer try. When you run it, okay, inner try, inner is there. Okay, we say this. So what is happen when it try? Action 1 is call, and then try, inner try is executed, then action 2 is call, and we have error and we exception and print in the inner try. So outer is not printed because the in action 1 there is no error. The exceptions is type error is executed only, so it's only in the inner side. So only one error is, one type error is there, so it is only inner try is printed. So like the top module code said, the bottom of the file wrap to call to try and to the action 1 in a try handler 2. When the action 2 triggers a try type error execution, there will be two active try statements. One is action 1 and one on the top level to the module files. The Python picks and run just most of the recent try and matching exception, which is case in try inside action 1. So we like this way. Okay, so this is a okay, and we say like this way. Okay, we jump to the example nest syntactic nesting. For that we have just this is a, okay, we have like before we uncoding we have just required a so we just like try. So we have this copy the code. Okay, and just say this. Okay, here it is. So we have like here it is. Oh sorry, yeah, after that we have try this way, and just after that outer we have exceptions. Exception try statement outer. Let's copy this. Okay, and just this is to be comment. Okay, this way and just this way. Okay, so we have this and say this. Okay, here it is. So we have like try, outer try, then we go to inner try, action 2, except try type error, printing inner try, and then when you go to except type error, then outer try. So we have like it is a that case we have like okay, this way. Okay, just to be copy and say like this way. It is, and just uncomment it this way. So we having like this way. So this is also working same as the like this way. Action 2, sorry, action 2 is just removed. Okay, yeah, only action 2 is required. So this way inner is also executed this way also. So this is syntactic way of that like this way. So we have like this way. It's like this way. Okay, so this is like a synthetic action. We have the like action 2s which there, and say like this way we have like we say like we have that thing like the action 2 is like we just call to the try, outer try, and then we go to inner try, and then we like we have like we have inner tries there. Okay, then So we goes to like okay, it is okay, yeah. Okay, so it is there. Okay, so we jump to the like exception idioms. So like we have idioms, so we have breaking out of the like we have breaking out that uh, breaking out of the multiple nested loops go to. So you can note it down that all the points. So guys, we have like a breakout of multiple nested loops go to. For that we have like so like we have like some of the loops like we have for that we have like nested and then we have co exception are not always error. Okay, later. So just comment it. So we have like okay, it is. It is. So we have like so we have like class. Then we say like exit loop. And we say like we have the exception this class, and then we have like a colon. Got it. Okay. Then we have try. Then I'm going to do while. Okay. Then we have while, and then we say like true to pass that while loop, and then we are like for if in then function the range goes to the like okay, so we have if, then we say like I that greater than sorry, okay, greater than 3, then colon. If I is greater than 3, then we raise the exception in the exit class. So like we have exit loops, then we say outside that if condition we have like print, then we say like string loop 3 colon so percentage is for that printing format is like if we say print the I, and we say like go to the outside of the for loop, go to the outside of while statements, while loop, sorry, and we have the loop 1. Then we accept exit loop, then printing the like the continuing. Okay. Okay. Oh, sorry. Whole thing is outside the that class. Yeah. This whole thing is goes to the outside of this class, and this class has some like a pass only. Yeah. Yeah. That's why it's show that not defined. This way, in the loop 3 0, loop 3 1, loop 3 2, and loop 3 3. For that, like we have loop just pass to the move ons. So like we have so we have like a continuing. Yeah, so show that what is going on when we run that program. We have try, sorry, first we run that in class except loop exit loops executions pass, then tries go to try, while is run, true condition is follow, for I in range 10 if I is greater than 3. So I is 1 2 0 1 2 3 does not matter, and 3 also does not matter. If that I is 4, like I is 4, okay, so we have like I is this way greater than 3. Yeah, so I is when my I is 4, then if statement is follow, and then rise and exit loops. So rise and exit loops is there, then so it does not print anything with class, it does not contain anything. We just printing the loop 3. Okay. Okay, sorry. Okay, try, then this is run. First when the program is run, this class is run, then try is there, then go to the while condition is follow, for I is range 10, so I is that 0, and then we say like 0. So if condition is follow but print is always printing, okay, because it is outside that if condition. Okay, so we have like 0, so it's 0, like loop 3 0 is print, and loop 3 1 is print, 2 is print, 3 is print, and when that 4 is come, so it's rise in acceptance, so it's out, it is exit that this condition, and this condition, so it goes to the this way, and it's go continue this way. Okay, this will like this way. Okay, we have this way, just come. Okay, here it is. Okay. So like we have okay, jump to the okay, sorry, this to be, yeah, this to move this way. Okay, yeah, it's fine. Yeah, so we jump to that exception are not always error. Like we have in that we have like okay, here it is. So we have like the condition like while is for that while try is there, sorry. So we have like while, then we select true, then we say have try, then we say line this, and we say like input, and we say like accepts e. So it is a error, standard error, that read beyond the end of the file. So like okay, and we say like break, and we say like else, and we say like something like to process next line. Here is line like printing hi, here printing exit. So when we say like run it, so like this way. Okay, we have to be input some like one, so it's this way. Okay, so it's when we put one, then it's go to the like the oh yeah, again when I run it. Okay, we see like something like not okay, so it's always running. Okay, so like in that unlike the file method, this function does not return any empty strings. An empty string from the input means an empty line. Does it in the like e of error exception is just a signal in that that the context, not an error. Because of this behavior, we analyze the end of the file should terminate a script. Input often appears wrapped in a try handler and nested in a loop in the in this that's code. Okay, so several other built-in exceptions are similar signals, not an error. For example, calling system exit function, press Ctrl C on your keyboard, or either system exit and keyboard interrupt respectively. So we jump to that function can signal conditions with rise. For that we have like a user defined exceptions. There can always be a signal non error conditions. For instance, such as like just copy, we say like this, and we say like class, then found, uh, fo- then we say like accept, this way, and we say like pass, and we say like def, then we say like searcher, and we say like we have this, and we say like, rise, found. Okay, and okay, and this all are in the conditions. Okay, if that something like this way, this can be possible. I think so, not, but let us try. Yeah, this is fine. And we say else, and say like return this way. Then we have like try, and the searcher accept, then sorry, accept the founder is, then we say like this, success. Okay, okay, yeah, and we say like else, then we will go this way. So you can note it down it. So here it is, you can note it down that code. Okay, we'll continue like, so we have like uh, okay, this way when you run it, show that something like this. Okay, okay, we have just in that place we have to write something like this to be something like if this yeah, you can say this. Okay, this is something like this. Okay, this way. Okay, okay, there it is. Okay, so we have like so we have like okay, then we say like not defining this, so we have like we say like success to be something like true. It is okay. Then found this, then this way. Okay, then returns this. You can see it's like there's something calling a function here. This to be like a function. Here it is, something like this way. You can say like function something. Def dot success. This way. This to be like pass. And we see like this. Failure is this. Okay, what is failure? Failure like this in a function. Failure like this. And it's like pass. This is good. Yeah. Yeah, this is fine. I think this code is fine. Yeah. So we just this. See? Okay. So it's printing nothing because we just like we have some uh, it is so we have like so we have like okay, right. It is so we have like so we have like a founder. It is so we have like okay. For instance, our search route can code it to raise an exception when match is found instead of returning a status flag for caller to interpret. In the following, we have try except and else exceptions handler does not work for if else turn value tester. For generally, such a coding structure may be useful for any function that cannot be written a essential values of the to design it in success or failure. Like so function can like a signal condition will rise. So we have like we have a class that founder exceptions. So we have like function searcher. If success is there, if some function like we have call that function, then we found rise. We say like function. You can say like function. For that we have condition like true. Okay, sorry. We have the condition. If condition that follow like this way, this also some same. Okay. For that the founder that we have like success is true, that condition, so it's rise that error. If not, then we go to the return. So return is something like no error, no error, no error. And the success to show, so it's like it's returning like it return error. Here it is. So we have like founder that we have like found. In founder we have just printing that returning that returning an exceptions. Okay, so like okay, exceptions. So what type of that is round, right? Exception, then exception is like uh, is like returning something like function that calls. Okay, let's say returning it, so it show okay, founder that founders success this way, successful condition like the condition is this. Okay, if success is this, success this, condition like this, you can say success something like exceptions, success return an error, this something like true conditions. If if that condition, so we have to something like put something like I something, yeah, you can say input. The input is like input this way. If input is like is greater than 0, yeah, greater than 2, so that conditions follow. And founder right like this is something like pass. Okay, it is. This will then like we are finding that input, okay, something like in p, yeah, this will fine. If you input something like 1, so yeah, so we have like in the input something like type error is there. For that we have like type error, so we getting the error also. For that we have just condition that, so we have like okay, we have said this way also. You can say try, then say this. If you have any exceptions, like something can be any exceptions, then print that print like we have input, like we have say like input error 1. So we're getting the input error this way. Okay, so when I say input error is there, so we just convert that input to, like we say input to int. Okay, after that error, anything can be printed after that. Yeah, I say this is like this. Yeah, okay, it is printed. After error we say like input we type like int, convert to the int type conversion, int input dot in. So like this, and say like that. Okay, just okay, tries follow. Yeah, so this way we say like this. Yeah, no tries follow. Just this way. Let's do something input error, and then say this. After that, this, if this condition is true, and this way. Okay. So there are like signal conditions like we have. Okay, so we say like what is going on is try is executed, then search of this, then like this. Okay, searcher is this. Okay, this. Okay, yeah, this and this will be written, and we get the except dot follow, then success written in an error. It is to go not this way. Okay. Okay, we have the error, input error. Okay. This way we have this input. We have this. This way input error is there. And then we say like this. Okay. After that, it does not return anything. Why? If you say like print high, can this one be possible or not? It's printing high, but it show like this something space. Okay. Let's just do that and say, yeah. Okay, it do not go these conditions. Input dot int. So you have to be input. Okay. We say like input. Yeah, this will work fine. I think so. Yeah. Okay. So high. No, high is not printing. Execution cannot possible. Okay. Okay. This way and this and print high not is possible. Okay. Okay. then we convert to that int dot. Okay, here it is. So we're getting nothing. Why? Returning else, not returning anything. Why? I don't know. Then we go founder, then we have success. Then we founder shows pass. Then something like this. You can say like try error. Yeah, type error is there. Success. Okay. We can take this. Okay, here it is. So we have just take it to this and say like this, and we say 1 to show type error success return nothing. Why show the type error failure is go to, okay, it's go to the else. Okay, that's why it showed nothing. Okay, for that we have like success turn the error, then this way. Okay, like this. So failure, if failure we have just say like we have try inputs this way. Okay, just convert that input to int and say like input this way. Then failure like this. Found is this. Okay, here it is. We say 1. Okay, input is this. Okay, if you're not in it. Searcher on input. If you input this, founder is pass something, and founder is pass something like this. Okay, else is on failures. Look input. Okay, like pass. Here it is. So just run it again. Show nothing. Okay, we see like printing that input. Okay, nothing is going on to be. Okay, sorry. Yeah, 1 is print. After that, else is not. Okay, exception is to be like this. And okay, we have exceptions. This way we have founder. Error is there. One is there. Okay. one is there, so it's printing one. Then go to success, type error, success. Error, failure, say print, no error, no error, this way, error, okay. So it's going to the print E, okay. You show the type error, okay. Yeah, so show the error this way. If we say like we say input and this way, okay, so show the error. If we say like input, it's not needed anything. We say like this, we say like input, then say like this, so this should follow and show no error. So that's all. Like this way we can set a signal condition with rise, like this way, okay. And okay, we jump to the like closing files and server conditions, connections. The closing files and server connections. We have like closing files, like we have encountered the examples, like we have this code, like we have the file codes, the closing files. We have like files, here it is, something like files, like my file, like this way. We have a file, okay, we have some files open with like this, yeah, this way, my file. Like my files that opens, then we have like try, then like a for line in my lines and print lines, then we have finally then my file is like closed. Okay. So like we have a okay, as summary with through that like where exception process tools are all also commonly used to ensure the system resources are finalized regarding of whether an error occurs during the process or not. For example, some server required connection to be closed in order to terminate a session. Similarly, output file may require close calls to flush their buffers to disk for waiting customers, and input files may consume the file like we have like okay, input files may consume file descriptors if not closed. Also, file objects are automatically closed with the garbage connected if still open. In my Python, it may be difficult to show that when it's occur. Like we have like this way for my files. So my files will open like with the regular expressions with this way, and then we have write like we say in that we have say can we have the like write this way, and we have try, then we have like for my file line, for line in my files and print lines, and finally my file is closed. As we saw, some object make it potentially easier, and later we have a providing the context manager that terminates or close the object for us automatically when run it with the then statements. So like this. Okay. So we jump to the debugging with outer try statements. For that we have for that debugging we have okay, there it is. This to be as comment. Yeah, okay, that's fine. Okay, here it is. We have like try, then we say like run, something like some run programs. Say run program. Okay, and then we have like accepts, and then we say like input system, then we say like print like uncaught uncaught this way, then we say like system dot execute information. So that function system dot execution info function return the current exceptions informations like type comma value comma tracebacks. So return the information that most recent exceptions caught by the except clause in the current stack frame or in older stack frames. So that exceptions like this exception is all uncaught exceptions come here. So like we have this, and then we say like for that we want only the so we have three, it returning three type value and traceback. So we only needed the value, so we go to the one this way slicing. Yeah, you can say indexing. By indexing we just take the value. So like we have programs. Okay, we have like a program. Okay, here you can say program, we say like class. Okay, this way. Yeah, can say sorry. Yeah, we say like this. We say like run. We say like program. We say program. And we see like this, and we select program, just run it this way, and that program will some say like rise and exceptions this way. Okay, rise e, you say something like e. Yes, say e is not defining. Okay, we have programs. Rise e, name is not defining. Rising e is there. Okay. I see. So we create an exception SE this way. So okay. So we have like E is there. Founder that function. Okay. Okay. Okay, yeah, like this. And we say like e, then def dot e, and just say like pass. Okay. And okay. This way. Name is not defining. Okay, rise e. Something raised. Uh, okay. Like rise we have. Okay. Okay, this way. Okay. We've raised a type error paired from E. This way. Okay. You can note it down that this rise, like rise, we have this rise statements. Uh, So we have continued, like we have raised and then say like this way. Okay, so we have okay, rise is like we have okay, we have just copy this, like we have something rise to be like this index error, and we have raised as this, so we just create that exceptions from that. Okay, yeah, and note that just this is okay, so we just this and say like when run it, so it's show index rise as spam and is index then propagates. Okay, so it's rise is takes like a function, so we have like this way. Okay, then write index spam, so this way. So we have like indexing, we have like indexing, then we have like we have a try then rise index error spam. So like okay, so it's this way we can correct this sin this scenarios, like uh just to say this is this way. Okay, yeah, it will, yeah, it will better. Okay, here it is. So we have like this and we say like a rise, something like rise. For that we have to be something to be like, we say this to be a pass, we say like this to be like pass, and say like this way, pass it and say like this spam and propagate. Okay, like this, this has this has comment, so this has comment like so like we have a class program exception is there, so like this way we have so we have like if we run it, it show nothing, program pass it this way. So we have like we have okay, pass it, this scenario cannot be arised. Okay, so you have to be rise before that, yeah, rise e, so this I think so, rise is paste error. Okay, we have like this rise e with this, like we have this way. Rise e is the program that we have functions, program function is there, so it show that rise e with this, then we say something is not to be print. Okay, why you have to call that. Okay, and okay, index error rise e, we create that exceptions. Then we say rise e, this way we have raised e, Okay, we have the rise e with that. Okay, so in that module like systems we have okay, so we have systems, so we have module like providing this, and we have like this. Okay, okay, here it is. So system module, we have access to some object used to or maintained by the interpreter to the function that interact strongly with interpreters. Dynamic objects like this way. So we have static objects. Okay, this way. So if say like e, we say something like okay, yeah, name e pro. So we rise e is there. Rise e. We create something rise e. E is not defining. E is not good to this way. Why? I do not know. Okay. Like we have a here it is. So we have rise e. If you say index error, you can say an index error. It create an index error. Okay, we got it. Okay, here it is. So we go to the program pass. Yeah, and then we show index error and print got system. Something to print it or not? Yeah, it show that index error this way. Okay. What is the fun 0? Class is this index error. So index error is not anything. So it show this way. Yeah. So we have like okay, we're getting something. Okay. So we have like so we have in the debugging cell, like we have debug that like we run some program, then we say raised that if the program is something like this is for rise. So if you say some programs, sub programs is running, like we have program dot something like, okay, we can say some program is this, no exceptions, this, okay, some program is this. So program something like is running properly. If like we say for I in the range like this way, and we say like this, okay, and we say like okay, and we say like we print the, we want to print something like outside that range, like we say uh, we can say like it's not a range, yeah, something like I is something like string spam 0 1 2 3. So we want I at the 4, so it show error. So if that something like we have error, so if we say like program this way, if there's an exceptions, if then any exceptions there. I is not this. Okay, index show that this error. mm, okay, any error is there. Okay, we say return. Okay, say return. Yeah, say print. Yeah, you can say print also. Yeah, this way. Indexing error, if that any indexing error is there. But it did not go this way. Okay. Return the I S4 this way. Index error is there. Okay, here it is. So we have this index error. So I have to print something error. Uh, program dot this, and then we save this. This running, and we say like it returning the I. Okay, it running the I. And means we want the 4. Yeah, this will running. I think this will run fine. It's outside. Outside that function. Why? Okay, sorry, class. This is a class. Sorry. Yeah. Index error. Yeah. Okay. Yeah, I got it. Oh, finally, I get it something, which is. Yeah, you said this. Yeah, it's running fine. Yeah. Okay, that will show that this way. So it show that index is that string index out of the range. For that, yeah, that's running fine. Okay, we jump to the running in process test. For that we have like this to be as comment. Okay. Okay. So we say here like import system, and we say like this, and we say like we have imports. Okay, we have like imports log as assigning to some open. So what to be open, like with condition is appear for that. Okay, yeah, with yeah, this way execute it, and we say like open, and we want to some like would want to append a append. So open like this, the open function that it'll open the file and return a stream. So rise OSE error upon the failure. So it shows the OS error. Okay. For that R is open for reading, and W is for open for writing, and X for creating new files. A for open for writing or appending to the end of the file if it exists. B for binary, and T for text mode, and plus for open a text file for updating, and U for universal new line mode. Okay, here it is. So we have like okay. So from that from that test API. Test API. We have okay. Test API. Okay. This to be like stall. Okay. Test API port. Put the more tests, comma, run, next test. Then we have like test name. Okay, it is. And then we go something like def dot test driver function this way, and we go to while, and we can say more tests this way, and we go to this and we say like try this and say run test. Okay, it is more tests, and we also we can say like we have accepts this way, and we say like printing the field. Okay, and we say like test name function, then we say system dot execute information, and say like 2 is there. Okay, only 2 is needed. From 0 to 2 is the slicing is there, and then if file, then we say like log, and we say like else. Okay, we have say print that passed, then say like test name, then file, this to be as copy, and we say like test drivers. Okay, just open that and just append that this way, and so running in process test. So when run it, so like this way, test API this. Show failure because okay, you have to say it's to be installed in the terminals. Yeah, here it is. New window, here it is. So we say pip, like say pip install you can say like okay, it is. Just take it this way. Yeah, so after we say it as a test API. So test API is installing successfully. Install and just run it. So we just say okay, some is there. execution console. Debugs is there. Editors. Python interpreter is this. Wants to install something like test API. Test API is not there. Okay. Okay, we have like this way. What is there? No modules present in this. Test for test. No test API. How to install this? From okay. From here this okay. Test API is not present. So how to install it? Install test. Like to install some library in Python. Yeah. How to install it? Okay, package is this. Something like to be installed. If present. Okay. Package respiratory. Okay, respiratory can be installed this way also. So this to be in the respiratory, yeah. I think so, yeah. This to be in this something this test API library. Microsoft library is for fast and API this way, yeah. It will present in this way, okay. Test API. Local dot this, something this. More tests. Test API is not this. Something's there. Okay. So we have a respiratory Python build structures, and this is like this. Okay. We have frameworks. Two tools are there. This is just like this. URL. Okay. Just copy this. I think so. Okay. Let's copy it. Okay, getting something to be not, if not running, then move it. This is not possible, I think so. So we have more tests. So more test, we have something like we have say test names, more test. We create some more test, more tests this way. And say like print more tests. Say system informations is this. More tests. Say acceptance. Then we have error. Start. You can say start. Yeah. You can say start. We have def dot test name, and we say like this and say print, and we say like if we have if condition is there, if if test is like this, okay, run the next test, okay, we have to create this also. Okay, we have def run test this way. Okay, so run test, we have like for that we can say like this. Okay, so for that we have like more test. For more test we can have the functions like okay, run next. Okay, we have like this way. Okay, we have okay. So like we have okay, so we have like run next. Run next will be run next when the more test. Okay, so we have like run it, run next, try that. Okay, we say like input something like I think the condition is this is to be fine, I think so. Yeah, this way. Okay, So this is fine. And for that condition, if like if I length of I is length of I is less than this. Yeah, I think this will fine. If the length of I is this, you can say this length of I this. You can say like length of I is this. Then you can say the like test name. You can then it's fine. Then pass else we say like go to this and we say like pass and we say like accept. And length of I. Else system error. And return that I. Start. Okay. Let's run print. And say start. Okay. Start is there, but you have to go to this is also. You say test name. I is not defining. Okay. We have to pass the I. Okay, sorry. So next, start print return I. Return I is this. Start then return I. And then we say like test name then I, and we say like this. So we're getting the index error. Yeah, so yeah, in this we have index error. Okay, with this index error I. And this return this. Yeah, it will fine. Yeah, return the IS4. IS4. Failed. I think so. From this, try. Then we exceptions. Test I. Okay, sorry. It's true. Pass. Okay. So I think this is some calling is there. No. Input. Input. Int I input is equal to 4. Then that's true. Else में false आएगा. This is false. And this way, okay. And just I'm going to the inside. Let's try more. Okay, we have more tests. Then we have this. More tests is there. Okay. True. Continue. Missing one I. Okay. I think this is fine. It's to be removed. Yeah, it will fine. I think so. Yeah, it will work fine. Okay. It showed the test. Okay. Call this test name and this next is passed to this text name. Text name is this. Okay. Spam is this. The I is already present in this. I can say, okay, we say spam. Okay. Indexing error. Okay. So let's go this way. Nesting the test I return I. returning nothing. This way. Okay. This way. Test name. Then returning this to be run. Nothing's happened. Okay. Run I as indexing 4. Okay. So we have this. Then we have this, and we say like this. With test name, then returning this. Okay. Let's just take this as this. Okay. Test name is not okay. Just remove that test name. Let's do it this way. Yeah. So it's running. How this can be running? I spam. Let's run. I run nothing. Why? Okay. False. Yeah. Yeah. And okay, then print the. Okay, we want to print it. Yes, say return. Okay, that's why it's shown nothing. Okay, we want to print it. Print that. Yeah. So we want to print that thing. Nothing is printing. Why? I don't know. Okay, this goes to this spam dot as 5. Low is this. Okay, we just drop it. So we have this. Let's remove this and remove this. Same thing is happen. Okay, so same thing is happening for this way. Okay. Okay. Let's remove this. Remove all of this file logo. Okay. System. Let's remove that system also. And say this. Okay. Failed. Now it's shown the fail. Okay. System, import the system. Okay, yeah. Okay, it showed out of the range. That's it, running fine. Okay, so we say the file signing to log. Log is not defining. Okay, I just say log. Log is as open dot example and then say AAP this way. So okay, yeah, oh, I think so, get it. Oh, sorry, yeah, it show the error, yeah, this way. That's why it show nothing. This is the way. Okay, we're getting the error. Okay, it's running, all the program is running fine. Okay, this is a good thing, yeah. Okay, that's fine. We're getting the no, not check that file, yeah. So it show that, yeah, it's append that index error. It happened many times. Okay, that's very good. Okay, so we jump to the like, okay, then we say like this. So we jump to the more on the system executive informations. Okay, so we have like try and then accept statements are there. Try statement and accept clause are there. For that, try the exception class of exception being handled. Value is the exception class instance that has raised. Traceback, the traceback object. Okay, this will yeah. It is. So we discuss the running in process tests, and we have go now in more on system executive information. So like we have traceback is the traceback object that represents the call stack at the point where the exception originally occur and used by the traceback module to generate the error message. So system executive information can also sometimes be useful for determining the specific exceptions type when catching the exception category superclass. We also learned that because in the class, in the case we get the exception type by fetching the system class attributes of the instance obtained with as clause. System executing information is often reductant apart from empty exceptions. So we have like now an exception handlers. System executive result used in last that code allows us the exception handler to gain the access to the most recently raised exception generically. This is especially useful when they using the empty exception clause to catch the everything blindly to determining what raised. So we have like the specific exception types that catch the exception category superclass. So we have just okay. So we have we have this exceptions like this where try and try statement and accept as general as instance. The instance that method does the right thing for that instance. Like we take the sum this way and say it general. You can say like general as ESG. Okay, yeah. So general as G. So this is an instance of that exceptions. Okay, so like this way also. Now we jump to the display error and tracebacks. For that we have like okay, we have some code. So we have like just as okay we have so we have like import, then we have traceback, and we have taf. Okay, function, then inverse x, and say return x this way, and okay, and we select try, and we have inverse 0, and then we have like except, then we have exceptions, then we have traceback, then comma dot print exhibitions, then we have file open, then we have some example this way, and say open, we want to write it as w. Okay, so we have like traceback, then we say print, so it so this action will print the in the this file. Okay, so we have checked that. We say like buy and just run it, so show buy, and the action of this traceback is appending in right in this way. Yeah, so show this way, 0 division error divisible by 0. So all our things are in the this way. Okay, so we have like okay, so we jump to the so this is a display error and tracebacks. So display error can display by this way. Okay, so we have like okay, here it is. So this is this way. Okay, so we jump to that exception designing tips and got edges. What should be wrapped? So wrapped like in the principle you could wrap every statement in the scripts in its own try, but the would be just be silly. The try statement would be needed to be wrapped in try statements. What to be wrapped is really a designing issue that goes beyond the language itself, and it will become more apparent with use. But for now, here are the few rules for thumbs, like operation that commonly fail. First rules. The first rule is the operation that commonly failed should generally be wrapped in the try statement. For example, the operation that interferes with system states like file opens, socket calls, and the like are prime candidate for try. However, there are exceptions to the prior rules. In second point, however, there are exceptions to prior rules in a simple script. You may want to failure of such operation to kill your program instead of being caught and ignored. This is especially true if the failure is a showstopper. Failure in Python typically result in useful error messages. This is the best outcome for more program, would we hope. And third point, you should be implementing a termination action in the try and final statement to guarantee their executions unless the context manager is available with an as options. The try and final statement form allow you to run code whether exception occur or not in the arbitrary scenario. And the fourth one is, it is sometimes more convenient to wrap the calls to the large function in a single try statement rather than literally the function itself with the many try statements. Okay, then we have like a fourth that what way of all the exception in the function percolate upon the try around the calls, and you reduce the amount of code within the functions. So we jump to the catching too much, avoid empty exceptions and accepts. So except handler generally is a key designing choice. Python, let us pick up and choose which exception you need to catch. Sometimes you have careful to not to be too inclusive. For example, you have seen the empty exception clause catch the every exception might be rise with code when try block runs. Easy to code and sometimes desired. You may also uh, like uh, like uh, like you may, but you have may also wind up the intercept an error that accept the try handler higher in the exception nesting structures. For example, the exception handlers such as the catch and stop every exceptions that reach it regard of whether the another handler is waiting for it. Like we have def function. Uh, okay, yeah. There is a def function. Then we have try, and then functions. Then we have accepts. Then we have like try, then function, then accept index error. Yeah, you say this way also. So like we have okay, we have, so like we have some code. Yeah, okay, here it is. We have like import system, then say def, then say by, then say this, and we say like this, and we like system dot exit, and then 40, then we select try, and this way, yeah, okay. Then we select by function, then we are like accepts all the exceptions, and select print, got it, then we select print, then select continue. Okay, this way. So you got it by, then we have exit, then we got it and continue. So you simply might not be expected all kind of exception that occur that could occur during a operation. Using the built-in exception class to pair with the chapter that can help in the pair particularly. So like we have okay. So we say like this way, and we say like this to be as comment, and we say like exceptions. So like this way. So this will would not catch the exit, but you will catch many others. So like okay, for that we have a class that have exceptions. Okay, that is building exceptions. In other cases, through that scheme to know better than empty except clause, because of exception is superclass. Above all, built-in exceptions except system exit events still have potentially to catch the exception mean for elsewhere in the programs. So like okay, so we have like this. So we jump to the last topic, that is catch too little, use class based categories. On other hand, neither be handler be too specific. With your list specific exception in try, you catch only what actually list is not necessarily a bad thing. If a system evolve to rise either exception in futures, you need to be go back and add them to the exception list elsewhere in your code. You saw this phenomena at the work and the pyro. For instance, the following handler in like written to treating my exceptions and normally cases. Everything else with error. So like we have like we are discussing like class based categories. Okay, So we have like class bit categories. So we have this, and then we say like this, something like my exceptions, my excepts, my except one. This way. So 2 is there, 3 is there. So we category that exceptions in this way also. You can say like we can also like success category names. So we have that also can this way. So in other, the little designing is goes a long way. The moral of story is to carefully to neither too general or not too specific to exceptional, to pick up the gradually to the try statement wrapping wisely. So that's all, guys. Thank you.